The first mod we're going to be doing is the Monotribe board. The main board has one part that's in the way of mounting our top board. For the most part, the top board can get around all the parts. You know, there's holes created for these caps that are mounted on the top. So in all cases, except for one, we can just disregard the parts mounted on the top of this main board. But there is one part, that's this trim pot right here, which is in the way, and there's no way to work around it for me because I want another added pot that's being added directly to the right of this pot, and so that's in the way. So that's got to be switched to the back side of the board. You can see here's the completed top board. That pot is sitting on top, and that's preventing this board from going all the way down to where it needs to go to sit. So that trim pot has to be flipped to the other side. Again, this is a mod for people using the output board. Now, this seems like it might be complicated, but it really isn't. Basically, you're going to receive, if you buy the boards, you'll receive a spare pot for this. So first of all, you don't have to worry about trying to desolder this from a plated through board and keeping the pot intact. In fact, the best thing to do, what I will do, save time, is just to cut this pot off immediately. So what I'm going to do, take a pair of sharp clippers and get in there and just cut that as close to the bottom of the board as I can. By the way, this trim pot, if you've seen my other videos, this trim pot is for balancing the differential amp of the VC8. So we're going to have to readjust that afterwards. I'll show you how to do that. Okay. All right. That's clipped off. Just clean that up a little. Now, first thing you want to do once you clip that off is to measure it, because it will save you a little bit of time when readjusting later. So using an ohm meter, I'm measuring from the left leg to the center tap, and measuring and marking down that resistance. I got 4.6, and then from the right leg to the center tap, and I'm getting 5.5. Now what I've done is I've taken the new pot and I've stuck it in this breadboard just to keep it in position, but you don't have to use it. If you don't have a breadboard, it doesn't matter. You can hold it and do it this way, but in any case, what you want to do is you want to set it so that it's the same as the one you just cut out, or close to it. So then when it becomes time to adjust it correctly, or as correctly as you can later, you're almost at the same point as the old pot was when it was cut out. But one thing you have to remember is you have to reverse the settings. So before you measured from the left leg to the center pot and the right leg to the center pot, you want to reverse those, because this is now being flipped to the bottom side of the board, so the part is being reversed. So what used to be set for the right leg should now be on the left leg, and vice versa. So I'm measuring the right leg while adjusting this to the previous left leg setting, which was 4.6. That's exact. And the other side, this one's a little different. The total value is a little different than the other one, but I'm close. I could do the final adjustment when it's back in place. So the next step after setting the pot close to the original setting is to solder it into place. Now there's two methods you can use. One is you're going to desolder these pins from the holes, and then you're going to, of course, insert the new part and solder it in. Personally, I don't really like desoldering stuff from through-plated holes. Sometimes I end up damaging the pad or the trace connected to it or something. It's a pain in the ass, especially if you don't have very good desoldering equipment. I have reasonable desoldering equipment, but again, unless it's absolutely necessary, I prefer not to bother with trying to get things out of through-plated holes. So there's another method you can use, because this pot, once you adjust it once, the chances are you'll never touch it again are extremely high. Maybe some years down the road you're going to go back and adjust it again, but again, either never or barely ever used. So I'm just going to tack solder it on top of the pins that are already there. So what I'm going to do is straighten these pins, the remaining pins that are in there from before. So now I've got the trim pot tack soldered on the back here, you can see. What I did before I soldered it in place is that I cut the leads of the trim pot about 1 millimeter, each lead 1 millimeter, just to make it sit a little bit closer to the board because the leads are quite long. And I bent them out slightly so that they would clear on either side the pins that were already in there. Then I fixed, I held it basically. Like I said, I pre-soldered everything and had some solder on the tip of the soldering iron. Then I just held it in place and I tacked one side so it was quite firmly fixed. And then before I soldered anything else, I bent it around and fixed it so that I could clearly see the adjustment hole through this hole on top. I bent it around and made sure that was accessible. Then I came back here and I tacked another side well. And then I tacked the third side. Then I went back and fixed up the joint on the last bit. And if you look at this from the side, let's see if I can get this in camera. You can see it's not exactly straight. It's a little bit tipped and crooked. But again, it doesn't matter as long as that adjustment screw is easily accessible from the top, because it is from the bottom, obviously. And it's very fixed. It's very good. So anyway, I did that very quickly. I did it off camera, of course. It didn't matter. But it was faster for me than desoldering those old pins, cleaning those holes out, and getting that pot installed. But again, whatever floats your boat, you can do. But so that one has now been dropped. Now this top board will fit all the way down like it's supposed to with the clearance we need. That's the unsoldered board, but here's the completed one. This one has already on the bottom, it has these soldered 3.5 millimeter spacers that are threaded. And now that pot's out, they all sit tight against the main board. So the last thing we need to do in terms of that pot is just readjust it now. It's best to do that right now because we're going to start removing some resistors and doing some other mods to this board, and which will make it not function correctly for a little bit. So right now, while it's still functionable, the best thing to do is plug it together and readjust this real quick, and then we don't have to think about it again. So to readjust this, we need to reattach. We don't have to reassemble the Monotribe. All we need to do is reattach the Monotribe's input-output board. We don't need to attach the battery board since that's only for battery and for sound output, and in this case we don't need either of those two things. So this is a handy tip to know when you're fiddling around and modding the Monotribe, is that you never need to attach this board unless you absolutely need the speaker output or you need the battery input. You can do a lot of testing and checking of things without having to reattach this board because you can just plug in headphones and listen to sound output that way. You don't need to use the speaker output. And generally when you're testing, you're running the device off the power supply, the adapter, not the batteries. So anyway, what we want to do is just reconnect this. To prevent shorts, I cut a little piece of cardboard here that I can use to just stick in between the two boards when I'm testing and stuff. So I'm just going to drop that into the bottom case. I'm going to stick this piece of cardboard in through there. Basically like that. Doesn't have to be careful or anything. Oh, one thing I forgot is we want to tap off a ground line for doing this. The easiest way I've found is these points, these screw brackets here, are all grounded, so I can just throw a clip on one of these. I'll do it on that side. All right. That's going to be my ground wire. All right. I'm plugged in now. Turn that on. Let me see where the, okay. Right underneath where this pot used to sit, beyond the mounting hole, beyond this hole here, is the differential amp. Sitting right next to that, to the left, are two resistors. They're R91 and R95. On the core schematic, they are these two resistors that are tied to V-bias here and here on either side of the amp here. We're going to be measuring at this point and this point to balance what's happening here. So what we want to do, we don't want the sequencer running. We want the thing to be basically quiet. So the two resistors are right here. R95 is below, R91 is on the top, and you want to measure on the right side of the resistors. The left side of the resistors is connected to V-bias and it won't change. R95 is the input to the differential amp, and that is the baselines. I'm reading my voltmeter right now. It's saying it's kind of flipping between 1374, that's 1.374 volts, and 1.375 volts. It's sort of right on the edge. And if I measure up here, this is on 1.376. So it's close. It's not exact, but it's close. But it means when I set that resistor before I installed it, I got pretty close to where it's supposed to be. That's why, you know, I gave you that procedure for measuring the old trim pot and then setting the new trim pot to those settings. So you'll be close to the ballpark once you've first installed. So what I'm going to do is I'm going to keep the probe on there. I'm looking at the voltmeter right now. Here, try to do this. Keep it in camera. I'm going to adjust that pot slightly and get it a little bit closer to where it should be. There we go. Fluctuating 1374, 1375. That's it. That's all you got to do. Now it's adjusted. Okay, the next step in modifying the mainboard is removing 6 resistors. There's 2 ways to do it. These are 603 size, so they're very tiny. So if you have a fairly wide chisel point soldering tip, you can put it right against both sides of the resistor and you can pop them out pretty easy with this. You can also obviously do it with hot air. I generally use hot air just because it can be usually less destructive than putting a hot tip down on the board. But either way, they're fairly easy to remove if you just got a little bit of equipment. These are the resistors are of such a tiny variety. You just want to get in there with something hot, you know, and a decent pair of tweezers. You're going to want to just heat it up and just wiggle that thing loose and pop it out. When you've removed those 6 resistors and you've installed this interconnect board, which goes right here, as long as this interconnect board is hooked up, you can remove all the other modular boards from the system, and you see there's a dip switch on here with 6 positions, and the 6 removed resistors are duplicated on this board, and you can flip those on, and so basically you can run the Monotribe as stock even when all the other boards are, you know, all the other modular boards are removed, as long as this one remains in place. Okay, so I removed the 6 resistors, 4 of them from here, 1 from there, and 1 over from this side. And so that part's completed. The next step is to clean the vias that you're going to use for drilling the mounting holes and running wires through. There needs to be 8 mounting holes drilled. There are 27 wires that connect the mad² modular boards to the main board. On the top here, there are going to be 6 wires, 3 here and 3 here, that go directly to the board, tap points. And then the interconnect board which will be going here on the back. So 21 on this board and 6 on the top. There's 27 tap points, 4 have to be tacked, 9 go to pads, that's 13, and that will leave 14 that have to go through vias on the board. We've got those 14 vias plus the 8 vias that are going to be used for drilling to clean out, because on the Korg board, all of the vias, pretty much every one, I think with the other, occasionally you'll find one, like I see right there, there's one via right there that is clean on both sides, meaning there's no solder in the via. But if you look at almost all the vias on here, there is solder, there's some solder stuck in the via, either on the back side of the board or the front. Normally it's the back side of the board, it's not often on the front side. On the front side, most of the vias are cleaned from the front, but the back side, they've got solder in them, and that will prevent us from sticking wires through those holes to solder to. And even for the ones you're going to drill out, it's better if you don't drill into it when there's solder stuck in there, because the drill might cause the drill to drift. So basically what I like to do is clean out all those vias first before you do any drilling or any soldering. So that's the next step. You can try to clean those vias out using desoldering equipment. You can try to suck, you can try to put a soldering gun on there, an unsoldering gun on there, and suck the solder out, but I found that often troublesome, and it doesn't work that well. Sometimes it goes, you get it, and sometimes it's a lot of work and you can't get solder to go out. So basically what I like to do is just clean those vias out with small drill bits. I have a drill index here of very tiny drill bits, right? And they're all different sizes, from the tiniest, plated through holes to bigger ones. While theoretically you could drill these out using these tiny bits in a Dremel or something, the chances are that if you use a high-speed drill, again, you might drift a little bit coming out, so you might not have a straight through hole, which could cause the bigger drill bit you're going to use later to drift even more. So usually I just like to do them by hand. It doesn't take that much time. It's reasonably easy to do. So here what I've got is a little thing that can hold tiny drill bits. Okay, I've cleared out 20 of the 21 vias I need to be cleaned, but I left one so that I could do it on camera to just demonstrate what I'm doing better. I've used 2 different drill sizes. The large drill size I used for all the ground plane vias and the vias that are on power traces. So 5 volts or the bias trace are using the large drill bit because they have larger via holes. Same with the ground plane, they are larger via holes. Most PC boards only use 2, maybe 3 sizes for the various via holes. So this is a larger size. It's 0.6 millimeters, 0.024 inches approximately, but you always want to double check before you do this, because the last thing you want to do is to, while you're working the drill through the via hole, you don't want to pull out the plated through copper. You don't want to disconnect the top of the board from the bottom board. So you want to make sure you have a drill bit that goes cleanly through without damaging the copper on either side. So the way you can do that is look for a via that's already cleared. Most of them are covered with copper, but on every board there's always a couple of each type that aren't. So for example, over here in this corner, there's one of the ground plane vias that's clear on the bottom and also clear on the top. And if I take, this is the drill bit I used for the larger holes, if I take that and I put that in, you'll see it travels through the hole without any problem. So if I was winding it through that hole, it wouldn't pull away the copper plating. So that was the larger holes, and there were 12 of those, and I did them all. The smaller size drill bit is about 0.33 millimeters or 0.0135 inches, and before I used that, I double checked. I found there's a line of vias here beneath the connector here that were clear of solder on either side, and I made sure that this drill bit could travel through those holes, you know, unimpeded when there's no solder there. So I want to make sure I don't take the plating away from the holes I do elsewhere. So the last hole that hasn't been done yet is one of the trigger outputs. And so what I'm going to do is I'm going to take the drill bit and get it inserted in that hole. It always goes in a little bit until it hits the solder. And then I'm just going to start turning it. Now, just be patient when you do this. You don't want to put a lot of pressure on. You know, I'm not putting any pressure on. I'm just letting the weight of the drill bit and the holder kind of go down in the hole. I'm just going to keep turning it just patiently. Often when you're doing this, you'll start to get solder coming out of the hole in long, you know, strings. Oh, that one went through pretty easy. So some of them take longer than that, but that's basically what you're doing. You're not, don't force it. Don't try to do any pressure. Just let it work its way through there naturally. You can see I pushed out some solder from that side, and that's the last of them. So I've done all 21 holes. Now the next step for me is to drill my 8 mounting holes. I've got the 7 ones up here, and I've got the last mounting hole. I already cleared out the solder. You can see it here at the back. It's this one for the interconnect board. I'm not going to film that bit, but just imagine I'm going to have this thing on top of a little bit of support, you know, a piece of wood or a couple pieces of wood holding it slightly off the drill bed, and then I'm going to drill them with the drill press. So I've drilled my 8 mounting holes. The 7 holes that are required for the output board, these take 2 millimeter screws, and the 1 mounting hole for this, it takes a 3 millimeter screw for the interconnect board. But I've drilled the holes larger because of, you know, errors in manufacturing and drift and all that. It's unlikely you're going to be able to make 7 holes at exactly 2 millimeters and have them match up to the threaded spacers. So I've drilled my 2 millimeter holes around 2.3, 2.35 millimeters, and I drilled my 3 millimeter one at 3.2, so slightly larger. And then I've deburred them to get rid of, you know, when you drill through a copper plane, you usually end up with a little bit of copper sticking up. You might sometimes, so I've deburred the holes with slightly larger drill bit. It was all very easy. One thing you have to be careful with, 5 of the 8 holes are totally isolated and completely free and clear of any traces around them, but there are 3 that are a little bit close. This hole here is a little close to those traces. Same with this top hole. There's a couple traces there, and there's 1 hole on this side that's close to 1 trace. So when you're doing those 3 holes, just pay special attention to the fact that you're not drifting towards those holes or something. I've tried to pick vias, you know, that are as safe as possible, but there are just a couple you have to be careful from. All right. When you screw this together, one way to make sure it's lining up correctly is you'll see there's places where there's holes made for the surface mount caps that are on this board to come through. Those holes should be, you know, relatively evenly placed over those caps. If the caps are jammed in on one side, top or bottom or whatever, probably you're not screwing it into the right place. Also, these 2 big holes here, there's mounting posts on the inside of the metal case that have to go through those holes. You know, the holes are a little bit larger than they need to be for the mounting post, so you should have some clearance even if there's a slight drift one way or the other, but that's just something else to help you you know, eyeball it and make sure you're getting it in about the correct spot. So let's just throw some of these screws in and see how it starts lining up. Okay, I'm not going to snug any of them up yet. I'm just going to look at the top. Those are matched up well. Those are pretty nicely centered around the caps where they're supposed to be. So yeah, that seems to work fine. So drilling at 2.35 millimeters seemed to do the trick. Snug those up. Okay, now we're going to just make sure the interconnect board goes where it's supposed to go. With this one, you put a screw through. This post is attached, and the screw is attached. Okay, close enough.